Wind energy and solar energy are the poster children for the green energy movement. Both are considered renewable and sustainable sources of energy, and due to their abundance, many view them as the eventual replacement for fossil fuels as our main sources of energy. The U.S. Department of Energy reported that 2/3 of all renewable energy installations in the United States were solar or wind related in the year 2015. With all the growth in the renewable energy industry over the past several years, especially from these two sources, it is important that we reflect on whether these clean energy sources of energy are indeed capable of providing us with enough power that we will no longer need to rely on fossil fuels. In the year 2019, 17.3% of Canada's primary energy supply came from renewables. The majority of this energy was produced by hydroelectric generating stations, which totaled 2/3 of this amount, while solar and wind only accounted for 0.6 and 5.3% respectively. The National Energy Board of Canada expects solar and wind to grow to only 1.2 and 9.5% of Canada's generation by the year 2040. That hardly sounds like a sustainable, abundant energy source that we can rely on. To explain this, we must look at the fundamental issues associated with wind and solar energy. The primary reason which solar and wind are difficult to rely on as a main power source is due to their availability. Although both are very abundant, at some point the sun will set in the sunniest of places and the air will be still in the windiest of places. This makes solar and wind unreliable. Unlike other emission-free energy sources such as nuclear, which can generate power nearly all of the time at full capacity. This dilemma has been at the forefront of the green energy movement for a while and explains the modest forecasts for solar and wind energy production moving forward. To solve the availability problem, we would have to find an efficient way to store the energy produced by solar and wind farms, making it available to us when we need it. That's where batteries come in. Lots of startups are being started to find a reliable solution to the large-scale energy storage problem. The current best option, the lithium-ion battery, works well in small consumer electronics such as phones, as well as in vehicles. However, the technology falls short when being used for large-scale storage. The expected battery life for lithium-ion batteries is only 2 to 3 years, and the technology generates a lot of heat and is extremely flammable, making it unsuitable for large storage capacity situations. The startup companies in this field are exploring different alternatives. In particular, flow batteries have shown potential for storing energy in large-scale applications and for significant periods of time. The vanadium flow battery, for example, has shown great potential due to its inflammable design. It is also able to discharge 100% of its battery storage and recharge fully afterwards. The lifespan for such a battery would be over 20 years, which is a huge upgrade when compared to lithium-ion batteries. The storing capacity of this design is dependent on the size of the electrolyte storage tanks, which researchers say would be a reasonable size if built for utilities in large-scale storage. Other flow battery designs are also making a move and seem like they can do a better job than lithium-ion batteries currently do. Lots of research is being done in this field, and our transition to a zero-emission society is dependent on finding a cheaper, scalable, safer, and longer-lasting design for our batteries. Thank you very much.